It says to find the surface area of the solid. Prisms, pyramids, cylinders, and cones are all right. That means they're straight up and down. Okay, looking at our theorem list, we're going to start with the surface area of a prism. Now they have pictured a prism that has a triangular base, but a prism could have just about any shape as long as it doesn't come to a point like a pyramid does. So that's what we're looking at. You could have one that has a pentagon. For a base. It's not a very pretty pentagon, but you get the idea. Okay, so the formula is 2 bases, because you've got one base here, and remember, surface area is if you were going to cover it with paper. And we have another base here, and then we've got the perimeter of the base times the height, because if we were to stretch out the paper that would be wrapped around the bottom of the sides of this, it would have like 3 sections here, and this would be the perimeter of the base going around this way, and then the height. So it's like a rectangle. Same thing would be true if you were doing a cylinder, which is another kind of like a prism, in that you're going to have 2 bases, and then you're going to take the distance around that cylinder and kind of roll it out like that. So this will be your circumference, and this will be your height. Okay, and we'll deal with the pyramids when we get to that. Alright, so moving back to number 4. Find surface area of the solid. So surface area, S, is equal to 2 bases plus the perimeter times the height. Okay, so the base equals, it's a rectangle that's length times width, or 4 times 5, so that's 20. And 2 bases is equal to 40. Now if you label everything, you'll be able to find what you're looking for. It's very helpful that way. Alright, now perimeter is 2 lengths plus 2 widths, and I've always told you length is really the longer number. 2 times 5 plus 2 times 4, it's not going to matter, but that's 10, plus 2 times 4 is 8, or 18. So we're going to do 2 bases plus the perimeter times the height. So surface area equals 2 bases, which we get from here, plus the perimeter, which is 18, times the height, which is 8. Okay, 18 times 8 is 144, plus 40 is 184. And I left off my units until now, but I'm remembering that this is paper, and so it's flat, so it's going to be feet squared. You always want to put your units at the end, and it's also helpful to keep track of your units as you go along. Okay, since we did 4 feet times 5 feet, we got 20 feet squared. That's where the units come from. Okay, now we have the surface area of a prism. Alright, now it's important at this point to be thinking about where the base is, because it could really confuse you on this problem. Where exactly is the base? And I've talked with you before about how to find the base. Let's see. The base of this cannot be the square that it's sitting on, because it's not coming to a point. Let's look at what happens when they come to a point. But what you want to do is find the base that when you slice through the object horizontally, obviously because you think of the base as what it's sitting on, you're going to get the same shape, identical or similar. Similar in that it's getting smaller and smaller, so that they're similar. There's a ratio between the sides. Let me see if I can illustrate this using another program that I have. Okay. go this way. Let's see if we can find what we need here. Let's see, prisms. I have a triangular prism here. Okay. If we turn this prism this way and we slice through it horizontally, we get a triangle that's exactly the same shape as the base. And if we can make it do that, that's what we want to do. See how that all those triangles are going to be exactly the same shape. See how that's exactly the same shape? Okay, and the problem is, if you were to cut that triangle differently and think of this as the base, look what's going to happen to it. See how that square, that rectangle, the rectangle is going to get smaller in one direction, but the length between the two pieces is not going to get strong. Let me see if I can say this. Let's go back to a triangular prism here and see if we can start from the beginning. Okay, watch what will happen here if we try to think of one of these rectangles as being the base. Let's see if we can get similar shapes. Okay, the length of the rectangle, the lengths are exactly the same, but the widths are getting smaller and smaller. So this is not a similar shape because the lengths of the rectangle are the same as the original lengths of the base. Let me see if I can pull it apart for you. Okay, well, this length is staying the same, while this length is getting smaller. So they're not similar. Remember, similar means they're going to change in the same proportion. So you can't use the square of that as the bottom. Oops, I lost it. Okay, so the only bottom that you can use for that, oops, that's a pyramid. The only bottom that you can use for the triangular prism is the triangle, because when you slice through it horizontally, you get exactly the same shape over and over again. Now let's compare that with a pyramid, a square pyramid. All right, now, would you use the triangle as one of the bases of the square pyramid? Well, let's put the triangle on the bottom, and let's slice as evenly horizontally across there as we can. And let's look at the shape we get. Okay, we started with a triangle as the base, right? But then we got a trapezoid. Let's go ahead and break that apart. See what happens? It changes the shape of it. So when you're talking about layers of things, like particularly when you're doing volume, you're going to have different shapes over and over again. So hopefully I'll be able to illustrate that a little bit better as we go along. Alright, so we can't be slicing through this thing this way, so we have to imagine it with the triangle as its base, because a triangle really truly is the base. So it really looks more like that. Let me see if I can draw that a little bit better if I bring it up close. So it's going to have an isosceles base, isosceles triangle base. This will be 5.7 and 5.7 and 1.6. Excuse me, that's not 1.6, that's 3.2. 3.2 is going to be the base, and it's going to look similar to this. You got to draw it artistically to make it 3D. Okay, and remember, this side is congruent to this side, and this side is congruent to this side, even though in the picture it doesn't really look that way. Alright, so let's find the area of the base. The area of the base is a triangle, and to find the area of that base, we're going to have to put a right triangle in there. Okay. So that would make this 3.2 divided in half. 1.6. And then we know that this length is 5.7, so we can use the Pythagorean theorem. 5.7 squared equals 1.6 plus, we know the altitude squared. 5.7 squared minus 1.6 squared equals 29.93, and we're going to take the square root of that. And we get 5.47. Okay, and we're doing all this because it really makes up the base. Okay, and I was showing you that right here too. So this is 5.47. Alright, so the area of a triangle equals 1/2 the base times the height. So that would be 1/2 of 3.2 times 5.47. And that's 8.752. And the best way to do this is to work it along with me. Alright, now when we unfold this paper, we're going to have a piece of paper that's similar to this. It's going to be 1.6 inches high, and then it's going to have a long side that constitutes that rectangle, and then it's going to have kind of a squarish looking base, and then it's going to have the other side that comes up the other side of that. So the length of this thing is going to be the perimeter of the base, which is 5.7. I don't mean to keep writing. Okay. .7, 3.2, and 5.7 again. So 5.7 plus 5.7 plus 3.2 is 14.6. So the whole distance along here is 14.6, and then the height is 1.6. So surface area is equal to 2 bases plus the perimeter times the height. Surface area is 2 bases. We've got 2 of them. Here's the base, the area of that triangle, 2 times 8.752 plus the perimeter, which is 14.6 times the height, which is 1.6. 14.6 times 1.6, 23.36 plus 2 times 8.752 is 17.504 plus 23.36. I'm adding them together now, so the surface area is equal to 40.864. 40.864, and that's in inches squared because it is area. And the directions tell us to round our answer to 2 decimal places, so that would be 40.87 inches squared. Okay, so there was a lot in there that we went over. Watch it again if you need to. Okay, so for a cylinder, it's 2 bases, and that's a big B base, plus perimeter, not perimeter, sorry, it would be circumference. Circumference times height. Okay, so to find the base, which is the area of a circle, we do pi r squared. R is 4.1, so when we square it, we get 4.1 squared is 16.81 pi, or 52.81. and that's in meters squared. Now we're going to find the circumference, which is different from finding the area. The circumference is pi times d, or some people say 2 pi r, which is not the same thing as r squared. Okay, the diameter is 4.1, so, excuse me, the radius is 4.1, so the diameter is 8.2 times pi. .76 meters squared. Now we needed 2 bases, but here we only have 1. So we're going to say 2 times 52.81. Okay, I'm going to rewrite this down here so you can see everything I'm doing. 2 times 52.81, because that's the base, plus the circumference is right here, 25.76, times the height, which is right there, 10. Okay, 2 times 52.81 plus 25.76 times 10. Now it's really important for you to know how to use your calculator well. If you have a Texas Instruments calculator, then you can just type that straight in and it will automatically make sure that it is multiplying before it adds, following the rules. Okay, and if we round that to 2 decimal places, that's what we have. Okay.